Hi dear students, this is Shiva Krishna, chemistry faculty. Students, today I am going to discuss January 25th, 2023 Shift 1 JEE Mains examination question paper. Actually, these questions which are appearing on my screen are completely knowledge of student memory based. So, students, any misconceptions or ambiguity in the questions can be resolved after the final or NDA question paper. So, now we will discuss one by one now. Yes, students, the number of lone pair of electron present in the oxygen in ozone. This type of question, generally this question is came from chemical bonding chapter. Now, number of lone pairs. This question is based on Lewis dot structures. If you know perfectly the question or previously if you know the molecule, it is easier for you, then there is no problem to do or to solve this question. Now, if any unknown question or unknown compound if they given, how to solve this type of question? Now, I will give you the logic to how to write this Lewis dot structures. Let us see ozone, they given, that is O3. Like this I can write as O as the central atom, because the three atoms are there, one of them must be the central atom, the remaining oxygen are the surrounding atom. How to write? I will give a small logic for this type of questions. N1, first calculate N1. Generally N1 is nothing but the number of valency electron in the given atom. That is, oxygens are 3, each valency electron are 6, the total number of valency electrons are 18. So, N1 is the number of valency electron in the given oxygen atom. All the total, this is N1 is nothing but sum of all the valency electron in the given species. N2, it is the number of electron which satisfy octet configuration other than hydrogen. If any hydrogen is there, you multiply with 2. That is, number of oxygens only present are 3. And each, if satisfies octet configuration, the total number of electron to be 24 electrons. Yes or no? Now, you take N1 minus N2. That N1 minus N2 is nothing but N3. That is 24 N2 minus N1, better to do. N2 minus N1, that is 24 minus of 18, that is 6. That N3 will indicate bond pair electrons. These are the bond pair electron. Let us take. You go for N4. Sir, what is meant by N4? This is N1 minus of N3. That is 18 minus of 6. That is 12 electrons. Generally, these are the lone pair electron if all the atoms satisfies duplet or octet configuration. This is the rule we can apply when all atoms are satisfying octet and any hydrogen like, that is duplet configuration if satisfies. Okay. Now, based on that, we please arrange the bond pair and lone pair in the given species. How? This is the central oxygen atom. This is the central oxygen atom. Let us take, these are the surrounding oxygen atoms. How many bond pair electrons they given? 6 bond pair electrons. 1 bond pair another bond pair you try to please, and one more bond pair is there, that is like this. So, the total bond pairs are over now. Now, this oxygen have 6 electrons around that. Now, to satisfy octet configuration, try to arrange lone pairs. One lone pair I am placing here. Now, automatically the central atom gets octet configuration. Now, remaining lone pair electrons are how many? 4 more lone pair electrons are there. That is 4 more lone pairs. Here 1, 2, 3. 3 2s are 6 lone pair electrons are over. Still 6 lone pair electrons are present. I can place here all the what is that oxygen atom which are present in ozone gets octet configuration. In this way, we can easily arrange or give the Lewis dot structures. So finally, ozone 2 bond pairs here, 1 bond pair here, and 1 lone pair on central oxygen atom, and the 2 lone pairs on the 1 oxygen, double bonded oxygen, and 3 lone pairs on the single bonded oxygen atom. In this way, we can give or write Lewis dot structures for the given unknown molecule, but here unknown molecule is ozone. So, what is the number of lone pair of electron? Lone pair of electron is pair of electron is nothing but pairs is nothing but 6 lone pairs. 1, 2, 3, 4, 5, 6. That is about the ozone number of lone pairs. Now, let us go for the next question, students. Yes, intermediate formed when phenol is prepared from cumene. This question is from phenol preparation from the what is that aromatic what is the phenols. Now, aromatic alcohols, phenol preparation. One of the question is cumene. Cumene hydrogen peroxide mechanism. When you treat with oxygen in the presence of light, first it forms cumene hydrogen peroxide. Cumene hydrogen peroxide, which on hydrolysis, for your convenience, simply I am writing like this happened. The phenyl shift occur, then we are getting phenol plus the byproduct is acetone. This is the general or regular examination question. That is why the intermediate formed is cumene hydrogen peroxide. This is the answer. Now go for the next question, student. Yes, which of the following will give flame test? Yes, student, they are the second A group elements. Yes or no, student? In the second A, what is that? From the top to bottom except beryllium, calcium can give brick red color, strontium give crimson red color, and barium will give apple green color in the flame test. So, by using this flame test, we can identify the given element. As a preliminary test, they are useful. This is the test for the second A group element by the flame test. Go for the next one. Yes, what is the correct order of electron gain enthalpy of noble gases? Generally, these 0 group element or noble gases have positive electron gain enthalpy. They have positive electron gain enthalpy. Generally, except helium top to bottom, electron gain enthalpy is decreases. Why do that helium has less electron gain enthalpy? Because of having only one s orbital and small size, their electron gain enthalpy is very, very less among the 0 group elements. So, neon is greater than argon, nearly equal to krypton, and xenon, and helium is the lowest. This is the abnormality. So, top to bottom electron gain enthalpy decreases except for helium. This is one more question. Next question, students. Yes, if X atoms are present in alternative corners at body center again, and Y atoms are present 1/3 of the face center, then what will be the empirical formula of the compound? Actually, students, here the question is based on solid state chemistry. Here X atoms are present, corners, alternative corners. For a cube, the total number of corners are 8. He said this is the cube. Alternative corners, that mean 4 corners only. And what is their contribution? For each corner is 1/8 part only, because each corner is shared by 8 such unit cells. Plus, what is that? At body center, whenever a atom or the ion or the molecule present in the what is that body center, it wholly belongs to that unit cell itself. That is why it should be 3 by 2 is the X number of effective atoms, and what about the Y atoms are present at 1/3 of the phase center. Actually the total number of phase centers are 6, 1/3, and each phase center atom or lattice point contributes 1/2th part. That's why 3 2s are 6 and that is 1. That means you please carefully observe why atoms are present 1/3 of the phase center. There are 6 phase center, 1/3 mean 2 phase centers only, and each phase center contributes 1/2th part. That is why half of the part, that is why 1. So X and Y, that is 3 by 2 is to 1, that is they are 3 is to 2. That means that X3 Y2 should be the formula of the given one. X3 Y2 is the answer. Okay, they are asking you in empirical formula, it is the lowest what is that ratio. Now reactions of NO2 in the sunlight of the photochemical smog. Actually these fossil fuels, when they burnt, produces different types of pollutants. Among these two different types of pollutants, there are two major pollutants are there. They are unburnt hydrocarbons and nitric oxide. This nitric oxide again combines into NO2. These NO2 again in the presence of light, they decomposes into, in the presence of light in the photochemical smog, they decomposes into nitric oxide and nascent oxygen. Again this oxygen combines with what is that oxygen in the atmosphere, produces ozone. Again this ozone combines with NO, again it become like this NO2. Like this the reaction is going to be occur. But they asked you that what is the reaction in NO2 sunlight of photochemical smog. This is the reaction taking place in the photochemical smog. That is NO2 decomposes into NO and O. This is the things are taking place in the troposphere. Okay na students, this is about the photochemical smog. Now go for the next question student. Yes, volume of 1.2 kg per liter solution of monobasic acid and needed to neutralize 25 ml of 0.24 MnAOH. When is such type of opposite solution they given, simply you can write number of milliequivalents is equal to number of milliequivalents of acid is equal to number of milliequivalents of base utilized. Number of milliequivalents of acid, that is nothing but 1.2 kg. Generally you can write molarity into n factor into volume is equal to molarity, volume in milliliter. Since I have written that is milliequivalents, and number of milliequivalents of base, that is molarity into n factor into volume in milliliters. Now molarity does not mention directly, they given in the weight, what is that weight. That's why I have to write the whole formula, that is 1.2 into 10 to the power of 3 grams by molecular weight, they given 24.2 gram per mole into how many liters? Yes, number of moles by gram molecular weight into n factor of monobasic acid is 1 and volume is required is equal to molarity, that is nothing but number of moles into n factor we can write directly also, but they asked you volume, they are asking you, that is molarity is equal to weight by gram molecular weight and 1000 by V, they given 1 liter, n factor is 1 and the volume we have to written here, and what is that 1 liter, they given 1 liter is nothing but 1.2 kg per liter, that is volume is equal to 1 by V, that is 1 by 1 liter, n factor is 1 and the volume of the solution still like this, and molarity they given is 0.24 into n factor of sodium hydroxide is 1 and the volume they given is 25 ml. Simply we can find out, that is number of milliequivalents of acid is nothing but molarity into n factor into volume. N factor for this monobasic acid is 1, volume we have to find out. For the molarity of the given solution is 1.2 into 10 to the power of 3 by 24.2 into 1 by 1 liter. Now after solving this all, you will get volume of the solution is 121 milliliter. This is the volume required to neutralize 25 ml of 0.24 m sodium hydroxide. Now go for the next question, students. Yes, half-life time is 30 minutes and find the time required for 75% of the completion of the reaction. Actually, that is given is the first order kinetics. Half-life time 30 minutes they given, find the time required for 75% of completion of the reaction. So T of is equal to 0.693 by K. By using this, we are completing. Actually, the given question is a first order kinetics. Actually, they have given like this. Then K is equal to, find the time required for the 75% completion of reaction of first order. K is equal to 0.693 by T of. Now for the time requiring, according to the what is the first order kinetics, K equal to 2.303 by T log of initial concentration by concentration at the time T. Then T is equal to, then automatically K value you know 0.693 by T of they given 30 minutes. Answer also you want in 30 minutes only, units. 2.303 by time and log of. Okay, find the time required 75% of completion. That means 100 by 25. Since after 75 completion, the amount of the reactant to be present is 25. 25 4s are log 4. Log 4 is nothing but 2 log 2. That is log 2, 2.303 into log 2 itself you can write that. Then T is equal to 60 minutes. Since 0.693 by 30 is equal to 2.303, 2 log 2 by time, this 0.693 and 2 log 2 values are remain same. That means that then time is equal to 30 into 2, that is 60 minutes. Actually the given equation is a first order kinetics. Half-life of the first order reaction is 30 minutes. Half-life time of the first order reaction is 30 minutes. Then find the required time for the 75% of the completion of reaction is the question. Now go for the next question, students. Yes, which of the following are paramagnetic? The number of paramagnetic species are, anyway you can write. Actually here the problem is vanadium, scandium, titanium, vanadium 23. That is scandium, vanadium plus 3, that is 3d2 is the configuration. If you go for the titanium, that is 22 is the atomic number, that is titanium plus 2, the valence electrons are again 3d2. Now chromium plus 3, scandium, titanium, vanadium. Vanadium is nothing but 23. 23 means the number of electrons are 4s2 3d3, that is vanadium plus 3, 3 electrons are out, that is why 3d2. Titanium is 22, that is nothing but 3d2 4s2, of that again 3d2. Chromium plus 3, 3d5 and 4s1. Okay, after losing electron it become 3d3. And nickel is the 3d8 4s2, nickel plus 2 means that is nickel plus 2, that is equal to 3d8. According to the given thing, there are 2 electrons, here is also 2 electron, here the 3 electron, here the 3d8. If you write like this, still 2 unpaired electron, that means all the atoms, all the given ions having minimum 1 unpaired electron, that's why all of them should be the paramagnetic, but the given option is up to 3 only. This is, I think, so integer question. Maybe they written like this. This is the ambiguity in the question. So don't consider this option. If not, that means all the atom having what is that? Unpaired electron. That's why all of them should be the paramagnetic. Now go for the next question, students. Yes, radius of the second orbit of the lithium plus 2 is x, and the radius of the third orbit of beryllium plus 3 will be. Generally, how to calculate the radius is the question from the atomic structure. Now Rn is equal to 0.529 into n square by z. I can write that as Rn. What is the radius of the second orbit? R2 of lithium. That is, I am taking as A0 and 2 square by z. That is 3 is the atomic number. Then let us say as equation 1. Go for the next one. What is that? Then radius of the third orbit R3. That is A0 into third orbit mean 3 square by what is that? Atomic number of beryllium 4. Okay, let us say as equation 3. Now you can do R3 by R2. Then what will be that? R3 of beryllium by R2 of lithium is equal to, then what is that? A0 cancel. Then 9 by 4 whole by 4 by 3. Then R3 by R2. R2 is nothing but they given as x. Since that is x, that is equal to 9 by 4 into 3 by 4. That is 27 by 16. That means that the radius of the Be plus 3 third orbit is equal to 27 by 16x. 27 by 16x. This is the formula required to do the problem. Rn, any orbit of hydrogen like species, is 0.529 into n square by z. This is the way we can solve the question, students. Now go for the next question, student. Yes, this is the completely based on organic chemistry, and here also a small thing is missed here. Between 3 and 4 they are given that H3PO4 reduction, but it has missed while they are typing. Don't worry, we will solve the question now one by one. That is given that paranitrotoluene, bromination, upon bromination, yes, there are two groups are there on the benzene. One is withdrawing group, another is the donating group. Whenever two different groups are present on the disubstituted benzene, according electrophilic substitution takes place with respect to the ring activating group, that is nothing but donating group. That's why the donating group will allows the incoming electrophile to the either para or ortho. Para or ortho. Para already blacked, that's why it comes to sit on the ortho position, followed by they have done reduction. Whose reduction? NO2 reduction, like tin HCl or iron HCl. They converts the NO2 group into NH2. With respect to methyl, the electrophilic substitution was occurred, since it is the more activating group. And later, what is that? Diazotization, HNO2 025 degrees, or NaNO2 HCl diazotization. Then it become diazonium salt. The NH2 gets a diazonium salt. Later it do H3PO2. Again the reduction, H3PO2 can cause a loss of nitrogen. It become oxidized into H3PO3 and it become benzene. That diazonium salt become reduced, and now what is that? KMnO4. That is strong oxidizing agent oxidation, which will cause the benzene, that is the alkyl group become carboxylic acid. Still the bromine is present like that. So ortho-bromobenzoic acid should be the answer. See friends, one by one. That is bromination first, later on reduction, later on diazotization, followed by reduction, followed by again strong oxidizing agent oxidation. This is the thing, but here a small thing was missed, that is H3PO2 reduction. Now go for the next one, students. Yes, thionyl chloride on reaction with white phosphorus gives a compound A. White phosphorus, when they reacted with thionyl chloride, SOCl2 will be the thionyl chloride, which produces generally phosphorus trichloride plus SO2 plus S2Cl2 as the byproduct, students. This is 8, here is the 4 phosphorus and here is the 4 2s are 8 oxygens are over, still that is 2, what is that? S2Cl2. 8 2s are 16, 4 3s are 12, it should be the 2. So this is the balanced chemical equation. When the white phosphorus react with thionyl chloride, the product is A, phosphorus trichloride. Okay, here there is a chance or the easiness in the question. A on hydrolysis gives a compound B, which is a dibasic acid. Dibasic acid with phosphorus mean it should be the H3PO3. Since you see this is the S3PO3, 2 hydrogens only present. Yes or no? Removable hydrogens. That must be H3PO3. Therefore, the PCl3 when reacted with hydrolysis or what is that? Hydrolysis which produces H3PO3 plus of HCl. Yes or no? That means that it must be the H3PO3. Where is the answer? Here is the only answer. That's why there is a big chance for you. Here S3PO4, S3PO4, only dibasic acid. Directly also you can go for the answer without having any knowledge of the equations. Is it correct, students? Now go for the next question, students. Yes, compare the basic strength. Actually, the question here is, it must be gaseous phase or aqueous solution they should ask, but not given anything. If it is gaseous phase, that is tertiary amine greater than, secondary amine greater than, primary amine greater than ammonia, but there is no scope of tertiary amine any of the option. In any of the option having that is tertiary amine, that means that must be, the question must be not from the, what is that, gaseous phase. That means it should be aqueous solution. Whenever aqueous solution were they given, okay, is that according to our knowledge, what do you know? Secondary amine are the more basic than, what is that? Primary amine is greater than tertiary amine. Secondary, primary and tertiary should be the answer. Say yes or no? Secondary, primary, tertiary. So it should be the aqueous phase, while the alkyl group is methyl. If it is the ethyl, secondary, tertiary, primary is the answer. That's why it should not be the aqueous gaseous phase. It should be the what is that? Aqueous phase only. Now go for the next question, student. It is the easy and memory based also. Now, which of the following shows least reactivity towards nucleophilic substitution reaction? Generally, students, our benzene undergo electrophilic substitution. Their aryl halides, okay, if you take, generally they given the aryl halides only. Aryl halides did not readily undergo nucleophilic substitution because of the strong double bond character and pi electron density and their hybridization, all these factors which decreases the reactivity of aryl halides. But whenever electron withdrawing group either at ortho or para position, which facilitates the easy attack of nucleophile, we have discussed it previously like these things. Okay, so whenever electron withdrawing group either at ortho or para position, the aromatic nucleophilic substitution become faster. So check it, here is only one ortho, here is completely meta, here is the ortho and para, here is the para. But the question is least reactivity. Most reactivity is either ortho or para. Whenever ortho or para is present, after attack of nucleophile, the carbon ion gets stabilized. Yes. Let us see. Here is the leaving group. When the nucleophile comes here, it goes to here or it goes to here, again it goes to here. That means the negative charge will come to either ortho or para. If any ortho or para withdrawing group is present, that produced intermediate was stabilized by these withdrawing groups. But here there is no such type of withdrawing group either at ortho or para. That's why it should be the least reactive for aromatic nucleophilic substitution. Now go for the next question, student. Yes, the number of paramagnetic species. Previously, the question is the number of paramagnetic ions. There is a misconception. The two questions are from the same topic. Is it right? Maybe or may not be. We can't expect because the paper was not released by NTA completely. So let us see one by one. Nickel. Nickel, here the charge is -4. Nickel tetracyanide. Here -4. Then nickel is the +2. Whenever nickel is +2, the configuration 3d8 and 4s0. Here that cyanide is a strong field ligand. All electrons gets paired. No unpaired electron. No unpaired electron. Therefore, it is the diamagnetic. Now go for the next one, student. Same to same. NiCl4 and -2. Here is -4. That is nickel is +2. Again 3d8 4s0. But the chlorine is a weak field ligand. Electrons are not forcibly paired up. That's why there are 2 unpaired electrons. 2 unpaired electron. That's why it should be the paramagnetic. Likely here cyanide -6. FeCN taken 6 -3. Then iron become +3. Iron become +3. Now cyanide is a strong field ligand. That is generally iron is 3d5. 3d6 4s2. That is 3d5 4s0. Even though that is a strong field ligand, there is a chance of one unpaired electron. That's why it should be also paramagnetic. If we go for FeCN, here is the thing, students. Here is the -4. Then iron becomes the, this is the case 1, this is the case 2, this is the case 3, here is the case 4. Here is the iron is +2, that means 3d6 4s0. But here the ligand is the strong field ligand. That's why all electron gets paired. That means no unpaired electron. That's why again diamagnetic. You go for the copper tetrachloride. Here copper is tetrachloride -4 and outside is -2. Then copper is +2. Copper become +2. If copper is +2, that is 3d9. 3d10 4s1. That is 3d9. Still one unpaired electron is there. That's why it should be also paramagnetic. If you take copper -4, Cn taken 4, they given Cu Cn taken 4 whole power -3. That is -4. Here copper is +1. That means 3d10 4s0. All electrons are gets paired in this complex. No paramagnetism. Now go for copper +2. Again same to same. Copper +2. Here is the one unpaired electron. It becomes the paramagnetic. So nickel tetrachloride and hexacyano of iron, ferrite or tetrachlorocopper or aqua, what is that? Tetra aqua copper are the 4 compounds having the paramagnetism. In this way you have to write. While writing this type of questions, you should have the 2 things. One is electron configurations of the given central metal atom, and what is the ligand given. Is it the weak field ligand or the strong field ligand? Now let us go for the next question, students. Platinum hydrogen 1 atmosphere, that is standard hydrogen electrode, and iron +3 to iron. They given a cell equation. Platinum hydrogen H plus salt bridge Fe +3 to iron +2. That is the left hand side electrode oxidation, right side reduction. So it is the electrochemical cell. According to that hydrogen become 2H plus by what is that? Releasing 2 electrons. Now Fe +3 takes 2 electron, it become Fe +2. This is the reduction taking place on the right hand side electrode. The question is, find the ratio of concentration of Fe +2 to Fe +3. Okay, now see that, students. That is hydrogen gas 2 Fe +3 aqueous become H plus aqueous solution. Here is the Fe +2 aqueous solution. This is the what is that net reaction for the given electrochemical cell. To find out this E cell given, E naught cell they given. to find out what is the E cell and E cell not cell relation at different concentration by Nernst equation. E cell is equal to E naught cell minus 0.059 by N, where N is nothing but number of electron transferred, to log of product concentration by reactant. Product is nothing but H plus whole square. H plus concentration is 1m. 1 whole square means no need of that 1 whole square into Fe plus 2 concentration, that is Fe plus 2 concentration by H2 pressure of hydrogen, they given 1 atmosphere, into what is that, Fe plus 3 whole square. But here a small logic is there, students. Product concentration by reactant concentration. Find the ratio of concentration of Fe plus 2 to Fe plus 3. Directly they asked you. That's why no need of everything we have to solve. Then E cell is equal given 0.712 is equal to E naught cell 0.771 minus 0.059 by 2 log of product concentration by reactant concentration. Say yes or no? Now simply it comes like this, that is 0.77 minus 0.712 minus 0.059 is equal to minus 0.059 by 2 into log of product concentration by reactant concentration. Say yes or no? Find the ratio of concentration of the product. 2 is equal to log of product concentration by reactant concentration. You can find out the, I think the question is given log of product concentration by reactant concentration. Actually they given like this, that is the logarithm of product concentration by reactant concentration is 2. This is the thing they given like this, 0.771 minus 0.72, that is otherwise you can write like this also. Here is 2 Fe plus 3. Here is the thing we have done, that is sorry. Here is the Fe plus 2 is 2 Fe plus 2. Here on the squaring, that is 2 log 2 we have to write here. That is Fe plus 2 by Fe plus 3. That is 2 log of Fe plus 2 concentration by Fe plus 3 concentration. Yes students, that is minus minus are cancel, and log 1 we are getting, the things are cancelled. Here is 1 log of Fe plus 2 concentration by log of Fe plus 3 concentration. You will get the log 1. The total value become log 1. Identify the correct sequence of reagents of the following sequence. They given first N-heptane to A on gives B on acid, and that is benzoic acid. That means the given options, if you observe that Al2O3, Cr2O3, that means they are the aromatization or reformation. That means N-heptane 1, 2, 3. That means I can write like this, students, 1, 2, 3, 4, 5, 6, 7. N-heptane, which on Al2O3 or chromium trioxide, it become cyclization or aromatization is occurred. Now followed by chromyl chloride reaction, that is that converts them into directly aldehyde. CrO2 Cl2, they convert the toluene into benzaldehyde, and followed by concentrated NaOH and H3O plus. Concentrated NaOH, what they will do? Yes, if there is no alpha hydrogen, that is the Cannizzaro reaction, which converts benzaldehyde into benzoate and benzyl alcohol. That is the Cannizzaro reaction. Followed by hydrolysis mean we are getting benzoic acid. That mean whatever the thing they given we can get by first aromatization, followed by oxidation of the toluene to benzaldehyde, followed by what is that, Cannizzaro. These are completely based on NCERT modulars. Yes or no, students? Okay. These are the questions which are appeared in the 25th shift 1 examination student. Thank you very much.